Find the minimum value taken by fx is e to the power of x squared, where f's domain is the half closed interval from 5 to infinity. Okay, so the easiest approach here is to say that the derivative is this by the chain rule, and taking the domain of f into consideration, the derivative is going to be positive for any x bigger than 5. And now we just use that the derivative describes the rate of change of a function. And you know, the function is continuous at 5, nothing strange happens there. So f is increasing in the interval from 5 to infinity like that. And whence answer is the value of f at 5, which we write like that, and it's e to the power of 5 to the power of 2, which is e to the power of 25. So here we use the fact that the derivative of a function describes its rate of change. Find all inflection points of y is 5x to the power of 7 minus 7x6. Let's recap the basic recipe for how you find inflection points. You find and factorize the second derivative, then you do a sign study of it, and by looking at the sign of the second derivative you can immediately deduce where the function is convex and concave respectively, and then basically you are done. You can deduce from that where the points of inflection are. So for our function y prime is going to be 5 times 7 times x6 minus 7 times 6 x5. Y double prime is going to be this, and now you can see kind of why I chose y the way I did, because we get a simple factorization. Naturally we can break out x4 here. So that's finding and factorizing y double prime, the second derivative. Now you want to do a sign study of the second derivative. So we do that. You can draw a table, or you can do this thing here. So let's use another color. So this line goes through 1. Here you got this. Squares are non-negative. So here you got plus, minus, minus. And hence here, where the second derivative of g is positive, the function is convex. Here the function g is concave. Same story here. So g is concave in the interval from minus infinity to 1, and convex in the interval from 1 to infinity. I recommend you to write this out explicitly. And basically, I mean, actually g is strictly concave here and strictly convex here, and we see that g has a point, an inflection point, namely 1, because at 1 the function changes from being strictly concave to being strictly convex. So finding inflection points, find, factorize second derivative, study the sign of it, look at the sign of the second derivative to find out in which intervals the function is convex and concave respectively, and whence you can deduce where the function has its inflection points. So use this approach. Don't just put the second derivative equal to 0. 0 was not an inflection point of this function y. Follow this recipe for finding inflection points. Now it's time to do some indefinite integrals. With standard indefinite integrals, it's just like differentiation but backwards. Here, before I integrate, I'm going to rewrite the integrand as follows. So we don't like denominators, however constants are nice. Don't forget to write the dx at the end of integrals. Now we think backwards. Of course, if you feel very experienced, you could have gone immediately to plus 1/14 of x to the power of minus 2. And then also don't forget to throw in c at the very end when you have indefinite integrals. C standing for an arbitrary constant. Here, the t is the dummy variable, so we are integrating with respect to t. So pi being a constant integrates to pi t. And if you think about it, ln of the absolute value of t minus 2 does differentiate to 1 over t minus 2. So that's going to be answer. Well, plus e, yeah. And but here you should not be tempted to say that the answer is ln of 2x plus 12 plus e, because if you differentiate this, you would use the chain rule. You would get 1 over 2x plus 12 times 2. So how do you evaluate this integral then? Well, one trick is to rewrite it to break out 2, because then the derivative of x plus 6 is 1, and multiplying by 1 doesn't screw things up. And now you can think of the half as just hanging around. So that's one way to get the answer. So very careful if you integrate 1 over something. This is not equal to ln of something plus c unless the derivative of something happens to be 1. So just a general warning to keep in mind. And by the way, a more systematic approach would have been to use this substitution, but you would have ended up with the same answer, of course. Finding an indefinite integral such as this one is a little bit tricky, but not so hard with experience. So let's just do the division, so as to speak. Before you do that, let's just, break out a third to make life simpler. Now this division may not go out, but then we will just get the remainder, which is not the end of the world. So we do long division here. It doesn't go out, so the conclusion is that once you've taken out 4x plus 2 copies of x plus 2 from your polynomial, there's a remainder 1 minus 1. So this can be written as 4x plus 2, and then there is a minus 1 remainder, so you get minus 1 over x plus 2 there. So that's long division. Personally, I would be too lazy to do long division in practice, so I would just do it like this, because I know these two guys together become something nice. So then it's 2x, and then I have to plus 4, and so I just rewrite everything like this. Why do I do that? Well, because these that divided by x plus 2 is 4x, right? This become 2 when you divide it by x plus 2, and then we had that minus 1 remainder left. Now when we do the integration, the a third just hangs around, so it's and since x plus 2 has the derivative 1, we can here go to ln of the absolute value of x plus 2, and then don't forget the c.